Okay, so here's another practice of these type of problems. How many grams of sodium fluoride, NaF, can be made from 100 grams of sodium and 100 grams of fluorine? And then the second part, I'm going to ask, how much of the excess reactant is left over. So the first thing we got to do is we got to figure out how much or which reactant is the limiting reactant, right? So we go through the steps here. Step number 1, of course, is convert both grams to moles. So 100 grams of sodium. We know 1 mole of sodium has a mass of 22.99 grams, which means we are starting with 4.3497 moles of sodium. And we're starting with 100 grams of fluorine, right? 1 mole of fluorine, right? Fluorine's diatomic, so it's F2. So it has a mass of 38.00 grams. And so I'm starting with 2.631 moles of fluorine gas, F2, right? Remember that this is reactant 1 that I have, this is reactant 2 that I have, and for my second step, what I do is I figure out how much of reactant 2 would I need to use up all reactant 1. So I take reactant 1 and I convert it to reactant 2. So I take that 4.3 moles of sodium. I use the coefficients from the balanced chemical equation. 2 moles of sodium. We'll use 1 mole of fluorine. So that means I'm going to need to use 2.17 moles of fluorine, right? This is reactant 2 needed. And what I like to do is, what is this? 2.17 moles of F2 needed to use up all of reactant 1. So that's what that number is giving me, right? That's what that calculation has told me. I will need to use 2.17 moles of fluorine to use up all my sodium. Now, my third step is to compare how much do I need versus how much I have. And since 2.17 moles of fluorine, that doesn't look like F2, are needed, but I have 2.6 moles. I have more than enough fluorine. So can I use up all my sodium? Yeah, because what this calculation just told me was that in order to use up all my sodium, I will only need to use 2.17 moles of fluorine, and I have more than enough of that. So now, I wrote a little too big here. Now I'm just going to need to use this data and what I figured out, right? What did I figure out? Reactant 1 is the limiting reactant. That's sodium. So now I'm going to actually answer the question, right? I can start with the amount of sodium that I start with, 4.3497 moles of sodium. The balanced chemical equation tells me that 2 moles of sodium will be used to make 2 moles of NaF, and 1 mole of NaF, sodium fluoride, has a mass of 41.99 grams. So I will be able to make 182.64 grams of NaF. And now go back and look at significant figures, right? Both of those numbers have 3 significant figures. So I know my answer is going to have 3 significant figures. So it will be 183 grams of sodium fluoride that will be able to be made. So now I've answered that question, right? How many grams of sodium fluoride can be made? I figured out first that the fluorine, I would have more than enough fluorine to use up all my sodium. I would need to use 2.17 moles of fluorine, and I have 2.6. So using up all my sodium, I could make 183 grams of sodium fluoride, right? So now we have to, write a nice sentence that sums up the logic that I used. And the first thing I state is my limiting reactant, right? 100.0 or just 100 grams of sodium is the limiting reactant. Right? And then I say, in order to use up all of reactant 1, in order to use up all my sodium, I would need to use, right, 2.17 moles of fluorine. I have 2.6, more than enough. So reactant 1, or sodium, is my limiting reactant because it runs out first. And then we have the second part of this question. How much of the excess reactant is left over? First thing we do is we figure out, well, which reactant was the excess reactant? I just said sodium was the limiting reactant, so that fluorine must be the excess reactant. Start minus used equals excess. How much did I start with? Go back and read the beginning of the question. I started with 100 grams of fluorine. Now I have to figure out how much I used. I have to start with my limiting reactant, which was the sodium, right? So if I start with 4.3497 moles of sodium, right? The balanced chemical equation tells me 2 moles of sodium will be used for every 1 mole of fluorine, and 1 mole of fluorine has a mass of 38.00 grams. In my calculator, I get that 82.64 grams of fluorine will be used. Okay, before we move on, let's think about significant figures and decimal places because we're going to do a subtraction problem in a second. I know that I got this number from converting 100 decimal point grams of sodium. So this number would carry with it 3 significant figures, all multiplication and division. So that means this number would be 3 significant figures. So it would round to be 82.6, which would be 1 decimal place. 100.0 has 0 decimal places. The number that I'm going to subtract would have 1 decimal place. We always go with the least number of decimal places or significant figures. Since it's subtraction, we're doing decimal places. But when I actually plug it in my calculator, I'm going to use the unrounded number, right? 82.64 grams. When I subtract those, I get 17.355 grams, and then I round that to 0 decimal places. 17 grams of fluorine left over. Right? Start minus used equals excess. Again, the next question, number 57, right? You can, if you feel like you are, if you feel like you know what you're doing and you want to try number 57 on your own, try 57 on your own, and then you can just pull up the video to check your work, or we can go through the next one in the next video.